And welcome everybody to episode 2 of Too Bad for You in Conversation. Joining me today is Dr. John Gilleard. So John was the co-supervisor on my PhD. He invited me over to his home to record this. As such, you will hear some house noises. We were in John's study, but you know, the heater goes on and off. There might be some footsteps from the family. Water pipes, things like this, regular home noises. It's not too distracting, but just so you know, that is what's going on. That was the setting. But like I said, John was the co-supervisor on my PhD, so he's a veterinarian and studies parasites, gut parasites mainly, in livestock. Again, mainly, but he will get into that near the end. It was a great conversation. We talked a little bit about how he got to where he is. He was reluctant to give career advice, but there's some nuggets to be gleaned from there. We talked about Twitter. He's got a pretty unique take, I think, about Twitter, and especially from an academic standpoint. I know in my time in academia, many professors, researchers, whatnot, were kind of reluctant to use Twitter, didn't see the value in it, but I think if you hear John's take on it, that might change. We touched on academics doing outreach, which was kind of interesting if in comparison to the conversation I had with Jay Ingram on the first episode of Too Bad for You in Conversation. We went a little inside baseball talk on grad school, but again, I think it's interesting for people who don't know anything about research, maybe a bit of an insight into the lifestyle and stuff. And then, yeah, like I said, at the end, we get into the parasite stuff, the good stuff. We discussed a lot about One Health. So the idea that animal, human, environmental health is all linked. It's sort of a big thing in the veterinary medical, especially parasitology communities. We talked about treating human parasites and some of the issues that are around that, if you didn't know there was issues around that, and the role of Bill and Melinda Gates Foundation, the Bill and Melinda Gates Foundation, in that, as they're playing a pretty big part in that. So some interesting stuff about research at the end. But like I said, I want to thank John for having me over to his house. He's a really great guy. He was a great supervisor. And just super fun to talk to. I always really enjoy catching up with him when I'm back in Calgary, and it was lovely of him to have me over to his house and to agree to be on this episode. So I hope you enjoy. As per usual, we got the freak motif bringing us in, and then it's on to my conversation with Dr. John Gilleard. Enjoy.
It's funny when you sit in front of the microphone because your mind goes blank.
Yeah.
So whether I remember anything to talk about is the big question.
Wow. Good way to start. I want to say thanks for having me over. Thanks for having me in your home
welcome.
to do this. Yeah, and thanks for agreeing to do it. I appreciate it.
Yeah.
You're a bit of a guinea pig.
Yes, in more ways than one.
In this. But I think, maybe just to give people a bit of a sense, you're originally from the UK.
Yeah.
So why don't you explain your background in terms of what brought you here to Canada?
Okay, well, I'm from the UK, the north of England, just north of Manchester. I went to the University of Liverpool to study veterinary medicine and graduated as a veterinarian in a long time ago.
Yeah, sure.
Many years ago. And I worked in general practice as a vet for 3 years. And then I kind of enjoyed that, but couldn't see myself doing it for another 40 years.
Right.
So I was always interested in science and research. So I thought, well, maybe explore that. And actually, I actually thought I was going to be a pathologist, a veterinary pathologist.
Okay.
But people dissuaded me from that. So, oh no, you should do a PhD, do research. So I just toured around the vet schools in the UK and ended up in Glasgow studying parasitology. So it's an interesting example of where you go with your careers, because I had absolutely no interest in parasitology whatsoever before that point. And the only reason I went to Glasgow because I liked the people and the place. I thought, this is good. And so I went there and did a PhD in parasitology and then did a postdoc. And then at that point I switched from parasitology into more basic science of C. elegans, a free living model organism, looking at gene expression in C. elegans, because I thought that was a good way to understand worms, because I haven't talked yet about the fact I work on parasitic worms.
Mm-hmm.
And so spent 5 or 6 years working in very basic science in this model organism in the genetics department in Glasgow, and then came on a Wellcome Trust Travel Fellowship to Calgary. Again, complete happenstance. I knew a professor, Jim McGee, in the medical faculty here who worked on this model organism, met him at a meeting, and I was looking for somebody to host a fellowship to travel abroad, and he said, well, why don't you come to Calgary? So I looked up on the map where Calgary was. So, okay, that looks all right. So, and then ended up in Calgary. So I did 2 years that, and then went back to a faculty position in Glasgow, in the vet school in Glasgow, studying parasites. And then after 7 years of that, this is going on a long time, this explanation.
Fine, yeah.
But after 7 years of that, I heard a rumour they were setting up a vet school in Calgary, because there wasn't one at that point. And Jim McGee actually works in the medical faculty, emailed me and said, you should apply for a job here. So I kind of just emailed and didn't hear anything for months and months and months, and then eventually got a call from the then founding dean, Alistair Cribb, who said, why don't you come up for an interview? So I flew out not knowing anything about the place and actually having no intention of taking a job. I just got a free flight and thought it might be quite interesting to see this new vet school. But then when I got here and saw the potential and remembered how much we like being in this part of the world, we thought, oh, we might do this. And so we ended up coming out and got a faculty position here and stayed ever since. So we've been here 10 years now. That was a very long answer to that question, wasn't it?
No, I mean, it's good. I think it's like, I mean, we've had conversations about this before, but you said it right there. It's like, you never know where your career will take you.
Yeah.
And so you kind of just, I went to Glasgow because I like the people.
Yeah, absolutely, yeah. And most of these big career decisions, which turn out in hindsight to be big career decisions, at the time, actually, certainly in my case, I've never really thought of them as a big decision at the time. Right, it's been a decision to do something which seemed like a good idea at the time, which then leads to something else. And so, that kind of grand forward planning has never really been a strong point. Right?
So do you think that that's just your style, or do you wonder if like other people? Because I mean, I feel like that's sort of the mentality that I take in my position. Is I'm going in a direction that I know I enjoy. And opportunities will present themselves along the way, and you have to be ready to sort of jump into those. But you seem, I don't know, I feel like you're downplaying it a little bit. I just kind of ended up here, ended up there.
Yeah, there's probably an element to that. But I think the problem is, and with the graduate training program we've got in Calgary, the Host Parasite Interactions program, we do a big thing of career advice and get people in to talk about careers. The only problem with that is I think it's a good thing to do, but the only problem is with it is it's very easy to be smart after the event. So you speak to somebody like me and say, well, you've got a tenured faculty position and you've got a job you enjoy. How did you get there? There's a kind of, I don't know, tendency to say, well, I did this, this and this. But I guess in a parallel universe it could have gone horribly wrong, right? And you never know, right? So there's a kind of bias to asking people those questions,
right? Because
you're only asking the people who actually it worked out for. So so I don't know how much it was just pure chance, right? And you never know. I mean, you work hard and you do certain things better than others, and some things work out, but yeah, to the extent to which you can engineer it with a plan, I don't know. But certainly I've never projected like 20 years into the future and say, if I do this is going to get me there. It's been more, this seems like a sensible or something. Maybe you go on gut instinct as well.
Yeah.
Right? Is you kind of do, you know, some people say do the pros and cons list, and
right.
but actually you do that, and then your gut instinct gives you your decision anyway, right? I tend to think so.
It would seem odd too to, like, you know, if you're planning 20 years in advance, that's basically saying that you know exactly who you are going to be and what you want to do right now, and that will not change.
Yeah.
You know, if you think about it, I've heard it put one way that it's, you know, if you were 5 years old and you knew you wanted to be an astronaut or something, and you get there and you realize, well, no, those were the dreams of a 5-year-old. Yeah. So what is it now, you know? And
I guess that's what happened to me in reality, because when I was about 12, I wanted to be a veterinarian, right? And so, and actually,
well, you did that.
I did it, and I worked at it, and it was okay actually, but it wasn't a passion for me as a day-to-day existence beyond a certain point, right? So that's probably part of it. A lot happens over that period of your life, and you know, other things kick in. So so when you plan too far ahead, I don't know. And then as I say, when I did a postdoc, I went really into basic science, and that was good at the time, and now I've come back a little bit more to applied science, and so that's good for me now, kind of thing. So there's these changes happen, but some of them they're not really planned, I guess, is the point.
Yeah. So we're not gonna hold your feet to the fire then for career advice.
No.
For any.
It's not it's not advisable.
I mean, I don't know how many. I think we probably have some listeners that are graduate students or PhD students, or you know, on that road. But yeah, we won't.
No. But
we'll save it for an advice podcast.
Yes, exactly. But the other thing to say about it, though, is, and it's a bit of a cliche, but it's true. I'm sure that you've just got to do what you really enjoy, right? And if you can do that, you'll make some kind of success of it at some level, right? And then it'll lead to other things. And it may not go the path you imagine, but there's nothing worse than doing stuff if you're really not into it, right? And many people do that, and I don't think you ever really thrive if you're doing that.
No, and that seems like the worst possible position to be in, like on a day-to-day, if you imagine hating your job and having to go in every day. I'll jump over, we've had many conversations about this, and you might know where I'm going now, but you're not going to give career advice, but I know at one point you were advising students and academics to get on Twitter.
All right, yeah.
And I enjoy your take on Twitter, and I checked your following before I came over today, and you're blowing me out of the water. You got like 1,300 followers,
like
I think.
Which is decent. Quite modest, but when you tweeted about worms and sheep, I guess it's quite a lot, really.
Well, so this is my
topic.
This is my question. How did you do? No. But I mean, you did seem like, I remember when I was still in the lab working, I think we kind of got into Twitter at the same time. Yeah. And you were one of the reasons I was always interested in the medium and that kind of thing, and I thought it was cool, but you seemed to really push it, and I know that you got pushback from some of your colleagues and students and stuff. So what do you think, like, why, I guess you could explain, you know, what it is you like about it, and why you think maybe that some of these people are resistant to it. And I guess I'm interested in it too from an academic, like, you know, Twitter makes sense for journalists or celebrities or something, but as an academic, as a researcher, what drew you to it?
Yeah, well, other than the facetious comment about short attention span and all that stuff, which is probably partially true. But yeah, I think it's a really efficient, useful way to stay connected. That in a nutshell is my take on it. And
so to stay connected to your colleagues or the research community?
Both. News, general, what's going on, current affairs in your field of science, connected to colleagues on a personal basis. I mean, we're inundated by so much information, right? And we're all in that problem all the time, is you can't read everything. You can't find everything. As a scientist, you know, you want to try and keep abreast of your field, and there's different methods of doing that, including very systematic literature searches, which we do, but then you never read half of it because there's not physically enough time, and you never read 90% of it actually, because there's never enough time in the day. So what is the solution to that? And Twitter offers something of a solution. I mean, it's like anything, it's not perfect by a long way, and that's where it gets the criticism, right? Because I think some of the criticism of Twitter is almost like, let's focus on all the problems with it rather than acknowledging its value.
Right.
And so what I think it's a really efficient way. So I think I've said this to you before, when we look at the Twitter stream, if you tailor your following, you're tailoring it to things you're interested in. And so in a way, you're screening out a lot of noise of information just by virtue of your Twitter following, right? Or the ones you follow. And therefore, I find if I get up in the morning, or I'm stood in the coffee queue, or whatever I'm doing, if I've got 2 or 3 minutes, 4 or 5 minutes, and I'm looking through that stream and clicking on links, I'm getting information quite rapidly, tailored to things that I think I want to know about. And then the flip side of it is, how do you as a scientist get your message out there, make other people interested in what you're interested in, even let people know you exist, right? Beyond a certain narrow spectrum. People spend an awful lot of time doing outreach activities of this and the other. Actually, it's a very efficient way of doing it, right? Because it's, if you've got over 1,000 followers, most of them are not paying much attention to what you're doing, but a few of them are at different times, and so that's that all of those things, right?
Yeah, I mean, that's what that's what drew me to it too, was that I can curate sort of incoming information. And have it right there. People will say there's problems with that. You live in your echo chamber, but in a conversation we had, for you, that's not a problem.
No.
You're in the parasitology sheep worm echo chamber, but great, that's where you want to be.
Yeah, exactly. And I think it depends what your objective is with Twitter, right? And
right.
So the objectives I've just given, I think the echo chamber is an advantage, because it's an efficiency of garnering information, which is relevant to me, I think. Right? Now, if I was using it to look at an objective view of the world, right, across the board, it would not be a very sensible thing to think you're doing, right? Because it's really not.
It's not.
I don't know many people I meet randomly who look at pictures of worms and sheep and look at the genetics of obscure organisms, or look at drug resistance in a particular 99.999% of the population are completely disinterested in that, right? But if you're aware of that echo chamber, then it doesn't matter, right? It's an efficient thing. So I think, and I think that's one of the things that there's lots of criticisms of Twitter, isn't there? Of people say it's all full of rubbish and nonsense, but that's who you're following, right? If you choose to follow people who tweet rubbish and nonsense, that's what you get. And we've discussed this before. It's a little bit analogous to. There's no difference between Twitter as a medium or social media as a medium and everyday life. As we were chatting the other day and saying, like, if you sit in a bar with a group of people who have racist, sexist, whatever views, and engage, then that's what you're surrounded by. If you sit in a bar,
you're going to hear. That's what you're going to see.
And have conversations with people who don't have those views, that's what you see there. If you walk into a bar in Glasgow and it's a Rangers supporters club, and you go in with a Celtic scarf and start cheering for Celtic, you might have a few problems.
Yeah, you might get a bottle chucked at you.
In a way, I'm not trivialising it, because there are problems with stalking, and it happens, but a large part of it is who you follow and how you interact with that group.
Well, and I think you nailed, what's your objective?
Yeah.
What is your purpose for being on that medium? What are you trying to get out of it, or what are you trying to put into it? Right? So I think that's really important. And I hadn't really thought of it in that way, because I guess in the way that I'm using it now, I'm following a lot more journalists and news, trying to get a wider view. And you do see some negative things, or you see a lot of articles being written about negative experiences that people have had. And it's nice to you kind of reset my thought process on it. It's like, well, what is your objective? You know, like, and should you, you know, obviously we need some people out there pushing certain issues and talking about things, but those are the ones that are sticking their neck out. So yeah, they're gonna. You know. But do you think that this is why, like, colleagues and stuff in academia or whatever are reluctant to use Twitter? Do you think it's like they just don't understand it, or they see the negative and they're like, I don't want to be in that space?
Well, it doesn't sound like arrogance or patronizing, but I think a lot of people just don't understand it. Not because they're not capable of understanding it, but they've just never bothered to make the effort to understand it. It's a new thing, right? It's that thing, right? And I think that, you know, you get some people, and you can look at their profiles of, if all they ever tweet is about certain messages, and certain scientists do that on Twitter. They'll want to put out information about their latest paper or talk or prizes one of their students got. If that's 90% of their content, you know, that's clearly, it's almost like a propaganda machine for that person.
Yeah, or they've been told by their PR department, you need to tweet more.
Yeah, it's almost like, yes, this is a good thing to go.
Yeah.
And again, it's analogous to everyday life. If you go in a bar, I keep using a bar, I must say something about it. If you go in a bar and just talk at somebody about your stuff, it's not a particularly productive way to go about.
When they're going to tune you out.
Yeah, exactly. So again, it's how you use it, and it isn't actually that much different to everyday life when you just use the same principles. I mean, the other thing about objectives is you can use it for different objectives. Is that if you want to understand somebody else's point of view, who isn't your point, you can choose to follow those people. I don't think either of us are great fans of the current President of the United States.
No, I'll go on the record and say that.
But actually, you know, I've actually specifically followed a bunch of Trump supporters, right, for a while.
Then, just to sort
then
of
stopped
see.
After a while. But what it's kind of interesting, because what you see then is what message is coming out, and you don't necessarily need to engage it in that particular instance. No. And therefore you've explored, and it does make you think about things. So you can have a very specific objective and use it for that for a while, right? But for me, scientifically, it's good because, you know, your own research field is a bubble in itself, right? Right. And so what you can also use it for is if you start to follow people in fields which overlap but are not totally within your field, then you start to get information that you wouldn't otherwise efficiently
explore the boundaries of your...
And so I see scientific papers which I would probably not pick up normal. It's a bit more the lateral thinking thing, right? And come up with new ideas because I'm following on the periphery of what I do. And then it also, even with the outreach stuff, as I say, I don't do a lot of direct interaction with farmers and things like that, although I work on agricultural livestock parasites a lot of the time. I do a little bit, but not a tremendous amount, but I follow a lot on Twitter, and some of them follow me. And actually I've been to meetings and I've known people in those meetings simply because we followed each other on Twitter. Yeah. So there's all these different advantages to it, which are cumulative, I think. But you know, you've almost got to engage with it in order to do it, rather than just spend a week tweeting for a while and say, this is not good, right? So
right, yeah, no, I agree with that. It's a cumulative thing, and it sort of grows. Do you notice though that, like, when I don't know if you have the notifications on when it tells you when new people follow you or something like this, but like, do you notice that certain things that you've done or certain things that you've engaged in have increased your... No, you haven't followed it at all?
Well, so the following thing's a mystery to me, right? No, I really don't understand how you get followers, right? Really. I mean, because I go through...
Well, you've got a few of them.
No, but the thing is, you go through a period and, like, I'll go through a few weeks, and every day there's a few extra followers that just keep popping up. And then you go through like a desert with doldrums of followers where there's nothing. It's like, you know, and then there's another, and I've never correlated it to anything at all.
Okay, because that was what I was wondering. Because I can see, sometimes I'll see certain, you know, I either post about something or I post something that I've written that obviously is in somebody's field. Yeah. And they then latch on, and you get a few people here or there. But I was wondering, like, I'm not saying like, do you know the secret to get more? But I'm just wondering if you found like that there were certain topics that sort of really hit it off in your world or whatever.
Yeah, I guess. Yeah, I don't know really. I mean, I'm trying to think now.
I know there's some fans out there of your landscape photos.
Oh yeah,
that
that's right. Yeah, yeah. Sort of pictures. Well, that's a bit of nostalgia for the UK, right?
Yeah.
Sort of pastoral images of the UK, Lake District and Scottish mountains and UK. And then actually, sometimes you'll tweet something like that, and you do get a lot of engagement there.
Yeah.
But actually, that's another thing you've hit on. Actually, is that even within a bubble of people, you have more in common with some than others. So, for example, in the world of parasitology, right, as a research discipline, on Twitter, if somebody also likes hiking or something as well, right, and you're doing a bit of that, and they also like this and that, then I've met people at meetings, and you've immediately got more of a connection with that person, and you've only met them a couple of times, at an international meeting. But actually, it smoothed the conversations because you're almost like you know the person.
You've gotten
because you know a bit about their hobbies and their life a little bit, and so actually it kind of smooths the communication for people when you meet them. So yeah, so for me, it's just, I don't know, and it doesn't take much time, and I use it to find news links, and so yeah, it's a really efficient way of going about. So
there's a couple things that kind of came up there. For the outreach thing, obviously I'm interested in science outreach. Science journalism is now what I'm doing, but the importance of it from the academic side, because this is another conversation that I've seen when I was in academia, is the importance of outreach, and Twitter or not, whether it's Twitter or something else, how important do you think that is?
Yeah, that's a really good question, actually.
It's a difficult one, isn't it?
It is, and I don't really know.
But you do go out of your way to do events,
we do, and some,
you make a point of it to do it.
Yeah, I think there's a whole variety of different aspects to it, and there's different types of outreach, of course, right? So some colleagues do outreach without even thinking about it because the nature of their research means they're connecting with stakeholder groups.
Yeah.
You can imagine in medicine, it's patient groups for certain diseases, or veterinary side, it may be particular livestock groups, or all those kind of. So that's one kind of outreach. But then there's the other kind, which is more just general science education and outreach like that. And so I do both of those things, I guess. But the debate goes on in academia. It's very time consuming, right? And actually nobody's rewarded for it.
Not directly, I guess.
No, and actually you do it off the side of your desk kind of thing. And the universities are very keen for people to engage in it. But the flip side of that is there isn't a reward mechanism to incentivize people to do it. So
there's no real metric to measure it, though, either.
Absolutely,
if it's working or not.
No, exactly. You can measure the quantity you do, but you can't measure if it's good, bad, or indifferent, or effective, or whatever. And I think that a lot.
But what do you think the goal is then? Like, if you were able to measure it, what do you think the goal of it would be? Just like a general elevation of people's awareness of your work, or they would be more inclined to vote politicians that care about basic research?
Yeah, I mean, the biggest single cross-cutting, I guess, purpose is to increase the awareness of the importance of an evidence base and scientific investigation throughout everyday life, including if it's right from political decisions through to making decisions about your own health, or whatever it is. And I think that it's surprising how many people don't have an evidence-based approach to life, right?
Yeah.
And so their beliefs, yeah, the way you said then, it's like, it's like, I was trying to be diplomatic about it. Am I being too diplomatic?
No.
But there's a lot of people just don't think that way, right? And actually, it doesn't necessarily map onto intelligence either.
No.
You get highly, highly intelligent people who don't have belief systems based on logical deduction and evidence, right? And the thing about science is, as anybody in the business knows, there's nothing special about it. It's just having an objective view of the world and using approaches to figure things out which are objective, right? And that's really all it is. And so the whole science outreach thing is I think in terms of academics doing it, a lot of it is about encouraging that in whatever milieu you're in, right? So for me, it could be in the livestock community, but it could also be through the more general population, and using what I do as a platform to do it, right? So
yeah.
Yeah.
I just wanted to, it's like, well, yeah, I can see academics being, well, that's not my job to try and convince people that they should, you know, trust evidence, or not even trust evidence, but critically look at things, and, you know, and go about life or whatever that way, you know.
Yeah, it's bigger picture stuff though, isn't it? Because although it's not my job per se, my job description, I've got a job description, I don't think. I've not read it for a while, so I've forgotten exactly what it is. But I don't think science outreach is in there, right? I'm pretty sure, and I certainly wasn't recruited to do that. And actually, as I said, there's no immediate reward for it. I mean, in terms of any promotion I've had in the past, or financial increases, a merit increment, or, you know, it's never, you know, it's just not a factor, right? And many argue it should be. But in terms of why you do it, then I think it's more the bigger picture, that you have to believe, if you are working in science, the whole only sustainable future for it is if society supports it, right? You know, the very virtue of somebody like me being paid to do what I do actually depends on society actually believing and valuing in that whole scientific enterprise, right? And research and more academic approaches to things. So if society disconnects from that, then people like me are in trouble, right? So you could argue, although it's very big picture and long term and indirect, it's very much in my own self-interest to do it. I mean, not from a day-to-day basis, but in terms of the sphere I operate in, we're only sustainable as long as society buys into it. So if you take the opposite view, like say, well, no academics should be doing this, then you're in trouble, right? Because why would society buy into it if they never hear from anybody or know what it's it's the classic ivory tower, right? As if it's the ivory tower, nobody knows what goes on in there, then why would you ever support it? So I think it's more that indirect thing in terms of reasons. But the real reason, I suppose, on a day-to-day is it's quite enjoyable to do, and you like to feel that you've got some fractional relevance in the world. so you know, if you can kind of work outside your normal sphere and get people interested in what you do, I mean, who doesn't like that, right?
Yeah, who doesn't want to talk about what they do and have people be excited about it? So
that's probably the real reason most scientists do it, although I just probably, I don't know, did a very good, well, no, I'm not saying very good, a very big attempt to make it sound grandiose, and the reality is, if somebody will listen to me, then that's quite nice, right? So.
Well, now you got a microphone.
Yeah, exactly. There's nobody listening though.
Well, we don't know that yet. We don't know that yet. I'll get you the numbers once it goes
exactly, up. Yeah. But I think that, you know, so I think that's the real. But I mean, it's true of every walk of life, right? If you're interested in soccer, you're happy to talk about it and get other people interested in it. If you're interested in whatever, right? So I think what most scientists do, and I think science is a very peculiar thing because it's very specialized, and so it's very easy to feel that you're disconnected if you don't engage in some of that, right?
Yeah, or I mean the classic thing that you hear from science, you know, people listening to scientists or whatever, is that they don't know how to speak about it in a way that other people can understand, and things like this. And again, I don't think that this is, you know, you said like this understanding of science doesn't map to intelligence or what it, you know, it's just you're using a language that's common to you, whereas say pick a sports example, they might be talking about plays or things that you just don't understand. So I think that, I wonder though how much there is still this sort of, well, that's science, I won't understand that attitude from
in the public.
I wonder because I mean, you and I are both kind of in it, so it's tough for us to gauge what that is. But
or
I know
it's
that
boring, right? I mean,
or it's boring.
The other thing is that many people, when you speak to them, say, "I hate science; it's boring." Or, I was at school, and you know, at school I hated science, and that kind of thing. And so, again, I suppose that's there. And then there's the echo chamber thing. I was talking earlier about, I've done a small number of these public events like Nerd Night, which is in a pub, science talks in pubs, and a few things like that, and that's great because but I do wonder who that audience is. It's a bunch of people who like science anyway, right?
So in a way,
and probably half of them are probably graduate students from other places. I don't know, right?
Yeah,
so we say, we're doing public outreach, but in actual fact, we're in the pub talking to people who are quite similar to us. So I don't know, but I think, it's.
But what you just got to do what you can, I guess. I mean, you can't poll the audience every time and who's here and how do we bring in.
It's a fractional thing, and I think that's it's a positive thing. So it's an interesting. But the problem is time, right? Because I think another thing most people outside the system don't quite get is academics are actually quite busy people.
Yeah.
But it's surprising. A lot of people I don't think necessarily perceive that, and the number of times I've been asked, what are you going to do with your summer now the students have gone away? Right, and so you can see my lip starts to tremble.
Yeah. Try and catch up on all the other things.
Exactly. Yeah. So I think there's again, why would people know? I mean, I don't know if somebody tells me they work in an oil company. I have actually no clue what that entails. Right. And so if you never kind of worked in a university or a research environment, why would you know? But there are stereotypes and things about what we all do.
Yeah.
Right. And actually, what a lot of people don't realise is and again, it's that kind of outreach thing, trying to discuss and explain these things to people. Is people think of a professor as kind of like a school teacher, but maybe operating in a more specialised manner. Right.
Yeah.
That's many people's view of. But actually, certainly on the science side, I always say it's more like somebody running a small business, but under the umbrella of a bigger institution, right? So if you look at something like me, I have a lab, I have a dozen people in the lab. You used to be in there, so there you go. So and all those people have paid off grants, and so nobody pays their salaries if I don't bring money in, and so you've got to juggle, and we've got to have outputs, which are publications and those kind of things, and basically if I don't get enough outputs and get enough inputs in terms of grants, everything
falls apart.
And that's run on a small business like manner, right? You're constantly looking for where your next grant might come from, making sure papers are going out, making sure everybody's trained properly, it's managed properly, and so you're really running this little business within an institution. And again, I don't think if you weren't in the system you would have any clue about that, right? And why would you, right?
Yeah, and why would you? Yeah, it's interesting. Well, and it's something I've kind of juggled in my head a lot too, is this idea of, well, why would they know, and why should they know? I don't know anything about what you do or what the next guy does. And I've always tried to say that to people when I was doing my PhD. I would, so what is it that you do at a party or whatever, so I'm doing a PhD. Oh my God, that sounds so crazy. And I was just like, no, it's just another job. It just so happens that I'm doing this. You could do it if you put the time and the effort in, whereas what you're doing is building a house or something like that. It's like, I can't do that. I've tried. I worked with some friends doing that, and I was terrible at it. I was awful at it, and I knew nothing, and it's just, so I wonder, like, I mean, maybe I'm downplaying it, but I feel like there shouldn't be this mystifying thing about science, and it's like, I'm never going to understand what they're doing, and so I'm just not going to try to engage with it, or I don't know what they're doing up there in their lab, and so I don't trust it, or something like this. It's just another job. It's just we happen to
absolutely, and actually
enjoy opening up intestines and looking for worms.
Which is a bit weird, but
it is weird. But
you try not to think about how weird it is. Actually, it's best not to dwell on it. but and I actually you just hit on something else then about perceptions and things. I always think it's funny when people talk about graduate students. People think of it as again, it's a bit like now I said professors and teachers. People think of a graduate student as like an undergrad student, but just more specialised or whatever, right? But actually, as you well know, being a graduate student is more like doing a job of work.
Yeah.
Right? You okay, you've got some courses to do, and you're supposedly being trained when actually in reality you're having to train yourself most of the time is the absolute truth of it.
I put it as it's like a internship or like a tradesperson, how they have to have so many hours of on the job experience.
Yeah, and it's exactly that. It's on the job training. And so people do, when people say, "Oh, you're still a student," or that kind of thing.
I got that a lot.
Actually, yeah, exactly. But what people don't realize, it's actually a job of work which has deliverables.
Yeah.
You've got to deliver stuff, right?
And
so it's not just, you're supposed to be developing and learning during the process, but actually it is delivering. And the other side of it is, of course, if you look at where academic science comes from, the for want of a better word, the workhorses of that are graduate students, right? The people who actually boots on the ground doing the work, making it happen, are graduate students. So it is a job of work. It's not this thing of, oh, you're an eternal student, you're just learning stuff. You are actually delivering outputs, which, any one of us, as we all know in science, when you look at what you've achieved, you think that's minuscule. But when you add it all together, that's what pushes science forward.
Mm-hmm.
So these students that people say were only paid, $22,000 a year, which isn't very much.
No, it's not.
And you have to survive on that at the age people are at, are actually, as a cohort, really producing a lot of good for society, right? And not getting paid much to do it, right? So, and then there's a whole other thing in there, right? So, and again, these are not, I don't know how we got onto this topic, but it's really just about the reality of how universities operate and research works within it is very different to, I think, what the general public perceive, right?
Mm-hmm.
And as I say, it's not surprising in a way what that is, because how would you know? But yeah, it is quite different on all jobs, and that's another side of the science outreach, right? And maybe there's not enough of that done, right? Is to explain that, right? Because it's not just about the content of the science, but it's how scientists work, and how the system works, right?
Yeah, no, definitely. And I mean, I almost think that too, like you could say that even graduate students don't realize that enough.
No,
I mean, this might be a bit inside, baseball here for the people that are graduate students listening or whatever, but
they'll be shocked.
Yeah.
I didn't realize I was a workhorse.
Yeah.
But now it makes sense. Now I think about it.
But I mean, because I remember when I was going through it, it was always, it was just expected that you do this, and that still very much this was a one path thing to becoming a professor or whatever, when really, because you're doing this, like as you described it, on the job training, you're actually getting a variety of skills that can be taken to any number of different places. Like you're not so specialized, but I think even people within it don't realize that, and they feel maybe like, well, if I don't get the professorship or whatever, then this was a waste of time.
Yeah.
And what am I going to do? Because I'm so specialized, I'm overqualified, all this kind of stuff. And it's just, it's perception, I guess, and how you view your time and what you've been doing and learning. But
yeah, I mean, the skills you have to develop, and anything from analytical skills to communication skills. I mean, there's a lot of public speaking involved, right? Which many people don't get as much experience of. Project management.
Yeah, that's a big one.
That's a huge one, right? Because and that can be very varied, from interacting with many people to the opposite of dealing with something very complex, but whatever, right? So it's so all those things are skills which are transferable.
Yeah.
But again, it touches on another area, that the system does have challenges, though, right? I mean, in terms of, I think it's like many things, it's evolved rather than being designed, right? And so the system now is as we all know, there's many more graduate students than jobs in academia, but there's still the perception, as you just said, that people going into do a PhD or whatever think it's a training to become a professor. But clearly it can't be, because only of a small percentage of people actually follow that route eventually. So and then the flip side is the whole system depends on having large numbers of graduate students doing the work, right?
For no money.
For very little money. So if you're a cynic, you could say it's a form of slave labor, right?
Yeah.
So, and actually, some, like in every walk of life, some professors are better than others in terms of their way they manage those things, and some, like in any other walk of life, will exploit people and some won't. And you've got the whole spectrum of that going on, as you have in, you know, if you were working in small business or working in the oil industry or working in a hospital or whatever, right? So, but, you know, but the problem with the system is it depends on having graduate students.
Yeah.
I mean, if you had paid workers, so to speak, who were sufficiently skilled to do the work that graduate students do, it would cost 4 or 5 times as much in the system.
So is there no way around that?
I can't think of it.
Yeah, I don't know.
No,
yeah.
I don't think there is. I mean, I think that what you've said is really striking the balance between it, training people to for things which are useful for them in their future careers outside academia, as well as getting productive outputs on the research, and it's striking that balance, right? And I think you know, there probably needs to be more thought about those other professional skill development stuff within the system, right? And I think that's coming out. There's more recognition of it.
Yeah, I think so. I mean, I benefited from it.
Yeah.
You mentioned it, the host parasite interaction program. That's, you know, directly helped me get to what I'm doing now. So, and that was specifically showing graduate students that there's other careers other than
and that's
academia.
A great program. I mean, that it's the National Science and Engineering Research Council that have these 6-year grants for professors to build a graduate. It's not a graduate program, but a program for graduate students to generally develop their other skills outside their scientific expertise and make them ready for other careers and the rest of it. And so the whole idea of it is that, you know, anything from communication skills to project management skills to, you know, whatever, there's a whole list of them that really beef that side of the experience up, because, you know, probably if you go back 20 years, it was worse than it is now, where graduate students would just be, you know, quite often stuck in a lab and working away and doing very little else. So it's really a recognition of the fact that you need to train or allow people to develop, rather than, you know, it's part of the training and allowing to develop that wider skill set.
And some of the skills that you talked about that you feel are important for society to have: critical thinking, analytical thinking, you know, logic, deductive reasoning, that kind of thing. That can, if more people spread out and have that in different sectors, that's not a bad thing. Right. Let's get to the fun stuff, though.
Okay, what's the fun stuff?
Well, what your research?
Research.
What you're working
the fun
on.
Stuff.
I think so, and I think, you know, you mentioned parasitology. So people are fascinated by, you know,
or repulsed,
or both at once.
Yes,
I think it can be both. So I mean, what I want to discuss with you what your lab is currently doing, but also the concept of One Health. Yeah, it's something that I think is important, and I've seen a few science media sort of outlets touching on it and stuff. But I wonder if that's one that people outside of the veterinary medicine, you know, parasite world even know. So I'll let you describe the concept of One Health, and then maybe how some of the projects that you're working on that would fit in that mold.
Yeah. So the One Health thing's an interesting one because I guess it means different things to different people. So I'm going to do my usual thing of probably overcomplicating the answer.
We got plenty of time.
We were just waiting for this erudite, concise definition, and now you're going to get a whole lot of waffle.
No. So the world is black. It's not black and white.
Yeah. So One Health. I mean, the basic concept of it is it's recognizing that health, human health, animal health, environmental health, in terms of the ecosystem, are all interconnected. Right? That's the basic concept. And so in a research frame, to tackle world problems that need solving, then you have an interdisciplinary approach of people from those different worlds. So it could be medical doctors, veterinarians, social workers, bioengineers, whatever, and it's bringing all those different fields together. So it's a recognition of these integrating these disciplines to have a more holistic approach to things, and also cross fertilizing between disciplines. That's, I guess, the most all-encompassing way I could think. But then when you start to split it, I mean, originally it was a very specific. There's certain people who believe it has to involve certain disciplines, like integrating social work with basic sciences and things like that. And you'd be amazed the debate it rages on about how you define something, right? Yeah, but that's not One Health. This is One Health, right? Yeah. So there's a bit of that goes on. But I mean, I think the veterinary profession as a whole has embraced it because it places them. It makes it more easy to place their relevance in a wider context, right? So it's a good way to present
that, being that animal health and human health is inextricably
but
linked,
also ecosystem health as well. So, right. So again, you can think of environmental impacts. Animals might affect the environment, which might affect human health. Right? You can imagine cattle grazing will change an environment, deforestation may even change vectors which transmit a disease, which then has a knock-on effect, and that disease problem in humans, which is vector-borne, actually has its roots based in the change to the ecosystem, which may even be affected by agriculture and whatever.
Vector-borne being like a mosquito or
a tick or
a ticks or something.
Whatever,
So by changing the environment, you put those dangerous insects more in contact with people,
with humans, and wildlife encroaching into cities, and so it's just recognizing those changes, then bringing people together to do the research, and then I mean the concept's been around for a very long time, and different elements of it have different definitions. Like there's comparative medicine was probably or comparative health was another way to put it long ago. And if you're a cynic, I guess you could say people have been doing One Health forever, but it's just not been
labeled,
articulated in that way, right? And I think it's more about that. But then other people say, no, that's not true, because we're talking about bringing disciplines together which don't traditionally work with each other, like, for example, social sciences and the hard basic sciences. That doesn't happen traditionally. So this is about bringing that together. So different people have a different kind of view of it. But there are lots of good examples of it. The one I talked before about and actually gave a nerd night talk on it a few years ago was in 2015, the Nobel Prize for Medicine Physiology was awarded for the discovery of this drug ivermectin,
right,
which is an antiparasitic drug. It kills worms. And the original discovery of it was actually to control parasites in livestock. And actually it was commercialized originally by Merck, I think, which is the animal health division of Merck, and it was developed as an animal health drug because there's more money in it for the company, right? Because livestock, it was, and then eventually companion animals, dogs, cats, horses. There's money in developing drugs for that market, whereas unfortunately these parasites affect people in poor regions of the world and people living in poverty, and there's no market for it. So the original development of the drug was to control animal parasites, but much to the drug company's credit, they recognized that, and then it was repurposed for controlling certain human parasites. One is lymphatic filariasis, which is a worm which is transmitted by mosquitoes and causes elephantiasis. Some people have
this is
heard
the
of that.
Swollen limbs that you see in those photos and stuff.
And others is river blindness, which is another worm which is transmitted by black flies. Again, in sub-Saharan Africa is but other tropical regions as well. And so it was repurposed to control those diseases, and literally it saved millions of lives and reduced many millions of people from suffering. And so it's, globally it's an incredibly important drug, and it's now being repurposed to treat things like scabies, which is a really unpleasant disease caused by mites in many parts of the world, and other diseases as well. There's even talk about using it to control malaria by controlling the vectors, as an insecticide, right? So although that's somewhat controversial in terms of the detail, but the thing is that so that was recognized for its impact on global human health with the Nobel Prize, but its roots were in developing it for animals. So that's an example. You could argue that's an example of One Health, right? Which is a discovery in animals. Which,
yeah. Well, and the incentive to make a drug like that, like you said, wouldn't have come about unless it was in the animal side.
No, exactly. Yeah. And that the whole thing of parasitology, because we haven't really introduced parasitology as a topic, I guess, so we're assuming people know what we're talking about, which is again an occupational hazard. But so parasites are organisms which cause disease or detriment to the host organism, and traditionally as a discipline it covers, really, if you want to simplify it, anything outside of bacteria and viruses or fungi.
Right.
So anything which isn't a bacteria, virus, or fungi, but which parasitizes something. So
the worms are the one that people always think
worms of. But ectoparasites like lice, fleas, they're characterized as parasites. And then single cell things. So malaria is a protozoan parasite, and that's considered as a parasite. So malaria, there's sleeping sickness, trypanosomes. So there's a whole group of these organisms which comes under the discipline of parasitology. And in human health, generally, bit of an oversimplification, but the majority of them have big impacts in the developing world. Yeah. And are diseases of poverty, many of them. And so therefore there isn't much of an interest from the developed world, even on the academic side, and certainly on the commercial side, for tackling these diseases relative to other diseases. I mean, you can get more traction trying to cure baldness than trying to cure a disease that affects 500 million people, right? Yeah. So because of that, human parasitology is very much a neglected discipline. Veterinary parasitology is somewhat less neglected because there's a commercial market for it, right? And so that makes the private sector interested in it, but also because it's not just the commercial side, but because it has an impact here as well. So livestock parasites affect agriculture here. People have animals which are companion animals, they're affected by parasites, and so there's an awareness in the developed world of a need to do something about them. So it's one of those fields where actually the veterinary side in many ways is ahead of the human side, right? And so there's a lot of translation of ideas and drugs from the animals. In fact, all the major, well, not all, but the majority of the major drugs which are actually used to combat major parasites have been developed as from the animal health side. So certainly on the worm side of things, not just ivermectin, which I talked about, but there's another class, benzimidazoles, which again are the major treatment for things like hookworms and other roundworms, which infect 1 billion people in the world. A single class of drug which is used to control that in humans, again, was originally developed for animals. Right. So again, there's a kind of trend of because the drivers of
so if we didn't have a need for, or a market for farmers wanting their livestock dewormed, we might not have any of these things.
It goes back to almost the beginning of the conversation on Twitter where that these kind of indirect effects, right? You would never think, what's the connection between a farmer wanting to control or increase production and growth rates in cattle could lead to saving hundreds of millions of people having a disfiguring disease in sub-Saharan Africa. Yeah. Right? If you put it that way, I probably should have paused that before we did the whole conversation. It would have been a much more interesting conversation. but so I think you look at that connection, it's not obvious, but so and One Health again is if you think of, the other side of it, which isn't my field, but is something like, and this is not an accurate figure, but gives you an idea in the ballpark that 90% of infectious diseases of humans emerge from animal pathogens, right? There's something like that, right? So
that's like the viruses, flu jumping into the
viruses, but of their origins somewhere in their history from animal pathogens, which have jumped, be it in the case of flu, like you say, in the last 15 years through to certain bacteria, which is hundreds or thousands of years, but there's this jump from animal to human.
Well, pathogens. Ebola, that's a big one, right? That people will know.
Exactly. So all those. So again, controlling animal disease has
beneficial.
a direct impact, what's known as zoonotic diseases, which are diseases which are transmitted from animals to man, and obviously water and health has a big role to play there. And actually, again, that's something else when people debate about definitions. The zoonotic disease, those things transmitted from animals to man, are the ones that always hit the headlines because they're the obvious ones, right?
Mm-hmm.
So flu is, like you said, swine flu, bird flu, transmitting crossing to man, TBs and other, which so there's a whole variety of ones where they're clearly animal pathogens which are jumping.
Mm-hmm. So, and that's, I think, the thing that I highlight when I think about it. That's what I think about, and I think that's what most people in the articles that I've seen written about it is. It's important to control animal diseases because they might one day jump into humans.
Yeah.
But the whole first part of it that you touched on is one that people probably don't think about, is that the animal side is driving the discovery of some of these things that can then be, and I maybe it's weird. People think because it's like, well, that's a pill or a drug that you give to cows. I can't take that. It's going to kill me.
No, exactly.
No, it's going to kill the worms in you just as good as it killed them in them.
Yeah, and there's other examples as well. There's in the news last week. There's the Lasker Prize, which is one of these big science prizes, which is quite often the people who win the Lasker Prize go on to win the Nobel Prize.
Mm-hmm.
And it's a British veterinarian actually who discovered a new anaesthetic back in the 80s, propofol, which is like a really cool anaesthetic. Basically, you can give it and then people recover from it almost instantly. Like you can, it's a really safe, rapid. Although I think it's the thing that Michael Jackson died from. But
overdosed on.
It can be abused, but anyway.
His side note, just a note.
Sidebar, but I think so that's another example of veterinary research, or certainly a veterinary researcher producing a major, one of the most important anaesthetics has been discovered in the last 30 years, right?
Yeah.
So again, people, again, it goes back to the thing of research on animals. I mean, it's a whole other topic. Should we be doing it? What's it about? But actually, the impacts, both positive for animals and humans, are indisputable, I think.
Mm-hmm. So we really are connected right to it. So to be a bit more specific about what it is, that your lab's doing, you guys work a lot on drug resistance. Yeah. Yeah. And you recently got some funding from the Bill and Melinda Gates Foundation for a project, which I think should be noted. That's a very prestigious.
Well, it's good to have. I mean, it's.
I'll take it.
Yeah, but it's a good. Yeah, I mean, I can tell you the story about how we got to that project, if you like.
Sure.
I mean, it's so I mean, I work on drug resistance in worms, right? And
so how they become resistant to the drugs we're using to kill them.
So basically in livestock, again, going back to that story, whenever you look at animals grazing, they've all got worms. It's not a question of which ones have got them. They've all got them. It's a question of how many, really. And there's a variety of species, and some of them cause lots of serious disease problems, and some of them just cause production impacts, i.e. animals don't produce as much milk or don't grow as much, and therefore it's an economic thing. And actually, where the life cycles of these parasites really are where you get feces contaminating the environment, which can lead to ingestion of contaminated
the worms
food
in their gut.
So if a sheep's pooing on a field, it's pooing on the grass, which it's then going to eat. That's a transmission cycle,
right? Because the eggs come out in the feces and then they re-ingest them. Yeah, right.
So because of that, they're ubiquitous, and because of that, these drugs are used very routinely to control them in a variety of ways. So drugs are used, and again, when we think about food production and pharmaceutical use, there's an issue there, but we use drugs routinely to control these parasites. So what unsurprisingly happens when you do that, as it happens with bacteria or even insects with insecticides, these organisms are then selected to become resistant to the drug. It's just natural selection in action, right? So if anybody who denies evolution, it's right there in front of you.
You could see it happening.
It happens real time, right?
Yeah.
So, and actually in some places in the world with sheep, for example, parasites like Australia, there's certain parasites which are resistant to every single drug that's available. So to buy drugs in Australia, a sheep farmer buys a drug, you can only actually buy combinations of 4 different drugs. They don't sell them as single drugs anymore because they don't work.
Wow.
So they sell them as combinations.
Super
of 4.
worms.
Yeah, exactly. Yeah. So that's been rife for many years and is getting worse, and horse parasites and now dog and cat parasites and the whole thing. But so I think and so we know quite a bit about drug resistance in worms of animals. There's still a lot we don't know, but nevertheless we know a lot. But in humans, intensive drug use is a relatively new thing. So, going back to the original things we were talking about with the One Health is, and a lot of people don't know this, 1.5 billion people are infected with gastrointestinal worms on the planet. So that's about 1 in 4 people on the planet are actually infected with worms. People don't realize, right?
Yeah.
So it's a huge global health problem. They tend not to kill people, which is why they don't hit the headlines. Malaria hits headlines, HIV hits headlines, TB hits headlines, but these diseases tend not to, because they don't kill. But what they do is they cause growth retardation, cognitive development retardation in young children. They cause problems with maternal health in pregnant women. Hookworm's the commonest one, which is basically a blood feeding parasite and causes anemia, and so they cause huge amounts of problems, social and economic problems and health problems throughout the world. So, but because they're in the countries they're in, sub-Saharan Africa, poorer parts of India, South America, and they affect those communities who are the poorest, where there's poor sanitation for the reasons we said, like the livestock, where you get fecal contamination of the environment, public health systems and sanitation, that's where you get the problems. Because of that, there's, going back to the original point, there was very little, not only is there not an incentive for drug companies to develop drugs, there's no economic model to actually deliver drugs. These people can't buy the drugs, so it relies on governments to have public
aid programs,
programs and the rest of it. So, and often that doesn't happen, right? And often you're dealing with parts of the world where there may be all sorts of, anything from civil wars to other social disruption going on. Yeah, exactly. So drug use traditionally in human parasites, and these particular ones, has not been very intensive for that reason. But about 15 years ago, the World Health Organization, in concert with the Bill and Melinda Gates Foundation and a consortium of, I can't remember, it's about 15 different drug companies, all got together and said, we need to do something about this. And basically there's been a big push coordinated by the World Health Organization, which has had a goal, but by the year 2020, something like 70% of all at-risk children will get covered with drugs once, twice a year. So that's been implemented, and they're almost at that target. And the good side of it is it's reduced the parasite burdens a lot in a lot of regions, and the diseases associated with them have been reduced a lot. The bad side of it is the more you do that, the more chance you've got of selecting for drug resistance. Right. And the one drug that they depend on for that control product is the same drug we use in livestock, as I said earlier, and is we know the parasites of this type in animals become resistant to that drug quite easily. Yeah. So
it's only a matter of time.
Yeah. So now we're in a situation where people are going to think, hang on, we need to look at resistance. Is it developing? But the problem is we don't have the tools on the human parasites because nobody really worked in this area. And so how do you detect resistance in these parasites? And so we've developed certain approaches on the animal parasites, which we're now going to apply on the human parasites to see if this resistance is developing, and how quickly it's developing, and where it's developing, and how it may be spreading. And so that was the funding we got from the Bill and Melinda Gates Foundation to do that work. So we've been doing it. I'm new to it on that side as an animal parasitologist, translating it to human. So it's the One Health thing again. And we've really been working on this project for just over a year, 18 months.
So it's really
early on, and so we're really developing the tools, and we're collaborating with a number of other groups, whereby we'll apply these tools to children in these mass drug administration programs to look at the parasite communities that they have and see, are these parasites becoming resistant to the drugs or not.
Mm-hmm. Would the idea be then that if you found the signature, the marker, you found a couple resistant worms in these groups that are receiving all this drug, what then would you try and tone it back? I mean,
that's a very good question.
That seems like you give them a hope and then take it away kind of thing.
Yeah. So then you get into a really complex issue about what you do about it. Right?
Mm-hmm.
So again, the first step is to define a problem before you can solve it, right? And define the extent of it. And so, the other complexity of this area is that the drugs that are used in humans are, because they were developed against animal parasites, are not really optimal for the human parasite.
Okay.
So they don't work as well as they should anyway. So if you treat an animal with one of these drugs, if it's working well, like, it'll kill almost 100% of the parasites.
Mm-hmm.
If you do it on a human with their parasites, like hookworms, it probably only kills about 70% of the parasites anyway when it's gut. And then you imagine it in these community settings where everything's suboptimal, deciding whether a drug is actually just suboptimal because of what I've said versus is resistance developing as a problem.
Mm-hmm.
And so how you tackle that, then in order to decide what strategies you need to tackle it, you need to define the problem first, right?
Mm-hmm.
So for example, the things we can do, which we know on the animal side, to slow down resistance, and one of them is not treat everybody at once. So when you treat everybody at once, you're applying very strong selection pressure to the parasite because you're applying the drug to every parasite there.
Right.
So the few resistant ones are going to be a big selectional advantage.
Yeah.
Whereas on the animal side now, what we do is we only treat a portion of the individuals,
mm-hmm.
and so therefore the selection pressure is a lot less because we're only applying the drug to a portion of the parasite population, allowing some of the susceptibles to continue to compete with the resistance guys.
Right.
And so, you could implement a strategy like that in human children.
Mm-hmm. So when you select that, though, to treat certain animals or humans, are you picking the ones that have the most parasites?
Yeah, there's different ways of doing it, and and how you implement it in practice becomes
mm-hmm.
very complex. But basically, yes, you want to target those individuals who need the treatment.
Right.
And the other side of this, we're going off. I don't know if this is too tangential.
No, it's all right.
It's good. But the other side of this is when you look at a population of individuals, most of the individuals have low parasite burdens and a few have very high parasite burdens.
Right.
And so if you think of that, it makes no sense to treat everybody the same.
Right.
Because there's a few people who really need it, and then there are others who actually are fine with a few parasites, right?
Mm-hmm.
And so the question then becomes, is it more sustainable to have a targeted approach where you treat those individual children who need it and leave the rest untreated, versus what's happening at the moment with a blanket approach of treating everybody,
mm-hmm.
right? And so you wouldn't implement, to inform how important or sensible it is to do this targeted treatment, you need first to decide whether resistance is a problem or not, and
mm-hmm.
if it's evolving and the rest of it. The other side of it is, up until now, it's all been about reducing parasite burdens to reduce disease.
Mm-hmm.
There's a big push from some quarters to try and go to elimination.
Just get rid of all.
So elimination means get rid of parasites from a region.
Mm-hmm.
Eradication is get parasites from everywhere, like smallpox has been eradicated.
Right. Yeah.
But regional, getting rid of something completely, is elimination, and global is eradication. So there's a move now to move towards elimination.
Mm-hmm.
Can we use drugs, or at least have drugs as a major tool to actually eliminate these parasites from a region? And many people believe that's almost impossible,
mm-hmm.
because it's all to do with sanitation. Ultimately, until you sort that, the drugs will never do it. Other people believe it's possible, and so there's big studies going on at the moment to actually. There's a pilot project, a huge project funded by Bill and Melinda Gates. It's about a $25 million project, I think, something like that.
Whoa.
Which is in India and sub-Saharan Africa. It's a number of sites to look at, is it possible? to eliminate from those regions using these drugs.
Hmm.
Now, the problem is, if that, the results of that, if there isn't elimination, is that because there's some resistant parasites, or is it because of other epidemiological factors to do with transmission, right?
Yeah.
So if you don't even know how to detect resistance, how to monitor it, you can't even begin to start to explore how to eliminate these things and what may. So really, it sounds like a really complicated answer why we need to understand that.
Mm-hmm.
But in a nutshell, if you can't measure something, if you can't define it, you can't tackle it, right? And
Right.
I think that's the nut of it. And so we're at a very early stage of being able to say, we're using these drugs, it's reducing the parasite burdens. Is that sustainable the way we're doing it?
Mm-hmm.
Right, and we'll only know that by seeing if resistance is emerging. If we want to use these drugs as a tool to eliminate them, is that possible? If it's failing, is it because of resistance?
Mm-hmm.
It's really trying to use the science to inform the strategy and the policy around using these drugs and having control programs. Right?
I mean, that makes a lot of sense. I mean, in a sense, yeah, it's like triage. How do we pick which people need it the most?
Yeah.
But there's all these other factors that you're bringing in that play a role into how do we even make that decision?
Yeah,
how
exactly.
do we even decide, if
What's
that's the right
strategy?
way, if that's the strategy? Yeah.
Yeah, because you wouldn't want to, if elimination, you really probably should be treating everybody, right?
Yeah. If you're trying to get rid of it altogether.
Because you've got to break transmission.
Mm-hmm.
Because again, we haven't been through the life cycle of these things, which
Yeah.
we probably need to do, but it's probably beyond what people want to listen to in
Yeah.
this podcast. But basically, in order to break transmission, you need to be killing all the parasites which are putting out eggs into the environment, right,
Yeah.
for a period of time, and eventually it breaks the cycle, right?
Yeah.
So if you then start only treating a portion of the population, that you're not going to eliminate it.
Yeah,
So
because there's
a
still
really,
people with parasites who are pooping out eggs
and
into
so
the
it's
environment.
going to continue on. So those are two very different strategies. Are we here trying to just accept that until the world is a much better place and we no longer have poverty and sanitation problems, we're stuck with these things, but we can use these drugs as tools to manage it and minimize the disease impact, right? Or are we going to try and eliminate them for even in the face of poverty, right? And obviously get some improvements to sanitation, but with limited improvement. So that's a big decision, and it's a complex decision. When you think of it, you're applying it to 1.5 billion people, right? As a group. So these are big decisions to make, and understanding whether the drugs are being used sustainably, and identifying where resistance is emerging. It's in this region, not that. How do we stop it spreading? That's why we need tools to detect resistance and monitor it, right? And so none of the rest of it you can really do with an evidence-based scientific approach if you do not know how sustainable the drugs are in the face of developing resistance.
How can we use these drugs if we don't know if they're causing resistance? Or no, that makes a lot of sense. I mean, makes sense to me. I think you did a good job of justifying why you got the Bill and Gates money. Bill and Melinda Gates.
Well, money. It's amazing with the Bill Gates story as well, isn't it? Because it's like if you go back to the 80s, he was, I wouldn't say, no, it's probably strong to say it was a hate figure, but many people thought Microsoft was the devil incarnate, right? The monopoly thing and the rest of that. But he's somebody who's taken his billions and is genuinely trying to improve the world for truly altruistic reasons. So it's an amazing thing. And the Bill and Melinda Gates Foundation, when you look at global health and neglected diseases, they're having more impact than anything.
Than any government,
before,
than
right?
any
university.
Absolutely.
So they're working in concert with others, but they're doing it in a way that is, bringing others on board and pushing the agenda. And they're very outcome orientated. They're not funding research. They're quite, as an academic, they're quite difficult to interact with for good reasons. That's not a criticism; it's a good thing because they're not funding it for academics to do interesting things. They're funding it to get a result. Right. We want this disease removed, sorted, controlled. How can we spend money to make that happen?
Yeah.
Some of it is implementation of new things. Some of it is doing the research that's needed to answer a specific question to achieve that goal.
Right.
So they're very outcomes orientated, right? So for academics like me, who, you know, I want outcomes, but I'm also interested in problems and how to solve them in a technical level.
Mm-hmm.
There is this kind of thing of yeah, that's fine, but we really do want you to come up with a result that's going to help us achieve this goal. Right? so the, you know, I think it's a very interesting thing. They are very driven to do good in the world, so to speak.
Yeah. That's a fascinating one, and you know, especially for these, like you mentioned a number of times, there's no money in helping poor people with these diseases, and so where is that push going to come from, if not someone who has all the resources and the will to do it? You know, because like, even governments are slow to act on that, and everything else. It is a kind of a fascinating thing that these two philanthropists, you know, billionaire philanthropists, have decided to take on challenges like malaria and the other parasite diseases. Like, it's pretty fascinating.
And the other example as well is Jimmy Carter as well, right? So
right.
The Carter Foundation. So there's another worm disease called guinea worm.
Mm-hmm.
Dracunculus is the kind of scientific name for it, and that's a horrible disease. It's spread by it's got an intermediate host where the infective stage is in a copepod, which is like a little
shrimpy thing that lives in the water.
It's a very, very small organism, and it lives in the water. People drink untreated drinking water, they become infected, and the parasite eventually migrates to tissues, typically in the leg, and then they actually burrow out. And these worms, when they're at foot, the adult, although the infective thing's microscopic, the adult worm, when it's grown in the leg, in the connective tissues and lymphatics, basically is like, can be a meter long, right?
Yeah.
And they're thin, but they're a meter long, and they complete the life cycle by bursting through the skin, and then basically spewing out their progeny into the water to infect these copepods. The process of bursting out through the skin is horrible, painful, and it's evolutionarily interesting because it leaves an open sore. But apparently, people crave water to cool the
relieve the burn.
So they run to the water, and then that completes the life cycle. So it's a fascinating but horrible thing, and the only way you could treat it, really, because you can't treat it with drugs, because if you kill the worm, it then has a massive inflammatory response to it, makes it even worse, and then you can't get the worm out. So traditionally they have this treatment where you put a stick and then you wind it out slowly
pull it out,
so you just keep rotating the stick over days and weeks that gradually pull it out. It's an incredibly horrible thing. So there's this horrible disease, and literally millions of people, even back 15 years ago, millions of people were afflicted by it, and the solution has been as simple as filtering water to get rid of these copepods. And so but it sounds simple, but how you roll that out on a scale in remote regions of the world to actually achieve elimination is a massive undertaking. The Carter Foundation has really spearheaded this, and they're down to, and again, I don't have the figures, but they're down to something about 30 cases globally now. Yeah. Right? And so they've gone from millions and millions down to 30. Now, the big question is, can you actually eliminate it? Because the closer you get to elimination, the more difficult it is to actually pull that off.
Yeah.
Smallpox has been...
catch every single one.
Yeah, there's only 2 infectious diseases ever been eradicated. One is smallpox, which is, everybody knows about smallpox, right? It's a viral disease of humans. There's rinderpest, which is an animal disease, a livestock virus. Those are the only 2 infections that have ever been eradicated from the planet, right? Now,
right, because polio still exists. I think people think that polio's gone.
No, so most of these things, the prevalence is massively reduced, but they're still there, right? And so this would be the 3rd infectious disease to be eliminated, but it's down to the last few cases, and actually it's another interesting story to it. It goes back, another One Health angle for you here, because what's happened as we've got down to the last few cases is there's been an increase in reports of cases in dogs, because it can infect dogs. And actually it wasn't really recognised as infecting dogs. People kind of knew there was the odd weird case here and there. Yeah. And so it was kind of textbook stuff, like can also infect dogs, right? Yeah. But nobody really saw it.
Yeah.
But now they've got down to these really small cases. There's been more and more reports in dogs. So the worry is, well, the confusion is that just because now we're more attuned to looking at this parasite and there's more people interested in that? Or is it because it's now adapting to surviving another host?
You've pushed it out of the human population.
Yeah,
it's
and
moving
selection to do that. And if that's happening, will that confound elimination? Because now and in those parts of the world, you've got lots of wild dog populations.
Mm-hmm.
If it really took off in that, then the elimination attempts might get thwarted. So it's right on the verge of being eliminated. And Jimmy Carter, who I think he's about 94.
Yeah, he's up there.
He keeps saying, he just hopes he gets elimination before he dies, right? It's his kind of ambition to see.
Because he's put a lot of time.
Yeah, and he's been a really big. Well, the Carter Foundation has been the driver of this whole program.
Mm-hmm.
So that's another One Health story, I guess.
Wow, fascinating. I mean, we've been at it for over an hour now.
Have we?
So.
All right, we better stop.
Well, I mean, if it wasn't, getting late in the evening, we could maybe go on and on. Yeah. But we'll leave it. We'll cut it there, and we'll leave it for the next time. So. Just thanks again, John, for having me in your home.
No, it's great. Yeah,
sitting down, talk. Yeah. I enjoyed it.
I'm just wondering. I was very serious in this conversation. I think.
I don't know. We had some laughs along the way.
Such a rant at one point, but
no. Hey, I asked you to do it because you have a wealth of information, opinion that I think is interesting. So, no, it was great. So, thank you very much.
No, thank you. That's great. Yeah. And whole new experience.
Well, once again, big thank you to John for joining me for that episode. You can follow John on Twitter at John Gilleard. That's Gilleard is Gilleard. If you liked it, subscribe to the show, iTunes, Stitcher, wherever you're getting it. Leave us a comment. If you want to comment on Twitter, the show Twitter is at 2BradForYou. There's an Instagram feed there as well. I am at bvanperdon. If you want to get in touch with me with comments about this, the 2BradForYou in Conversation series. I hope you're enjoying it. Like I said, subscribe, leave a comment. That helps us out and helps me know what we can do better. As always, love to have the freak motif here, so thank you so much. Sebastian Aboud as well for our artwork. SebastianAboud.com, check it out. And we will see you next time on the In Conversation series. Thanks y'all for listening.